Hello friends, welcome to my YouTube channel Backbenchers. In this lecture, we are trying to solve the expression for E by M, that is charge by mass. E by M value, E, E by M value of electron. Before we work out the E by M value, let me first say something why it is necessary. Because what we know about electron, in cathode ray experiment, we know that there is a particle with negative charge known electron, and it also has mass. But at that time, scientist has no idea or no clue about how lighter it is or what is the charge, what is the value of charge of electron. So E by M value at least give a clue about the charge of the electron and also mass of the electron, although we don't know the actual value of charge and mass of electron. Let's begin the main topic, how we can work out the expression of E by M value. And in this respect, there is two method where we can use a magnet only, and in another case we use a magnetic field and a electric field. And the second method is actually adopted by J.J. Thomson. For this reason, he was awarded Nobel Prize, and this experiment was done by J.J. Thomson in the year of 1897. It is one of the greatest invention of 19th century. It is the starting of modern physics. So, at first, please concentrate on the diagram. In this diagram, here is cathode, in this diagram, here is cathode and here is anode, and we give a potential difference between cathode and anode to accelerate the cathode ray or produced electron. And here we put a magnet, and in the first method we don't use this electric field, we don't use this electric field. And let me work out the calculation of E by M value for the first method. Suppose for cathode and anode we give a DC voltage of a value of V. Value of V. Here we put a DC voltage value of V, and it accelerate to the path, like the path is in black line. When it come to in the magnetic field, it deviates from its path. Its path, and it hit the fluorescent screen. Here is fluorescent screen like ZNS or AGBR, and create a bright spot in this fluorescent screen, and C is the bright spot. And when it come into the magnetic field, it experience a force. Its name is Lorentz force. I explained in previous lecture. Please, if you want to know the Lorentz force, you can see the previous lecture. And the value of Lorentz force is equal to F equals to F Lorentz force equals to E, the charge of electron, multiply V, the velocity of electron, and velocity here in this area, in the velocity of electron, and H is the magnetic field strength. When the Lorentz force act on this electron, it wants to take a circular path, and the picture is like that. Suppose the electron come in this direction, and the velocity of electron is v, and and the Lorentz force act on this direction. Lorentz force act on this direction. Lorentz force. This is Lorentz force. This is Lorentz force. This is Lorentz force. And as the value of H is not changing, the Lorentz force also not changing. Lorentz force is also not changing. So it circulates in a constant velocity because the force is constant here. Lorentz force is constant here. So it circulates in constant velocity. Here also V, here also V, here also V. And for this circulation, it produced a centripetal force. You made in physics and what is centripetal force. Of course, the origin of centripetal force is Lorentz force. Origin of centripetal force is Lorentz force. So, and the value of centripetal force is equals to F centripetal equals to m v square divided by r. Here m is the mass of electron, v is the velocity, this velocity of electron, and r is the radius of curvature. This is the r. This is the r. This is the r. This is the r. R is the radius of curvature. And if we want to write down this in this picture, here we can write a circle. If we want to write a circle, this is R. It may be error in this picture, but what I want to tell you, it is maybe clear for you. We can tell that this force is equal, that is Lorentz force equals to centripetal force, that is EVH equals to m v square divided by r. From this expression, we can easily extract E by m value. So, E by m equals to V divided by RH. E by m equals to V divided by RH. But here is a problem. We don't actually work out the E by m value from this expression in real situation, because we don't know the velocity of electron in this discharge tube. So we can transfer the value of V with known quantity. For this reason, we again consider another equation. What is this? If we concentrate from in this picture, here the voltage applied is V. It accelerated. Potential energy is converted to its kinetic energy. So we can tell that half m v square, half m v square equals to E multiply V. I write in this V as in the red color, because here V is the voltage. This is the potential energy of electron, which is converted to kinetic energy, and this V is actually the velocity of electron. Now from this V equals to 2eV divided by m root. if we put the value of V in this expression, suppose this expression is 1, in this one expression put the value of V in this one expression, we get E by M equals to 2 V divided by R square H square. We know what is the potential difference between cathode and anode. We know the magnetic field and we know the radius of curvature. And from this we easily work out the value of E by M. J. Thomson does not adopt this method because he want to express E by M value more convenient way. For this purpose, he apply the electric field so that the path of electron does not deviate. That is, it hit at point B. So here is no revolution. Here is no circular path of electron. It moves in a straight line. And if we apply this criteria, we can remove easily the value of R in this expression. Let me explain. Let me write down. When electric field and magnetic field operate in different direction, these and the electron does not deviate any direction, we can easily tell that EV equals to E multiply E. E is the electric field strength. Again, H is the magnetic field strength. E is the charge of electron. V is the velocity of electron. And V here, so V is E divided by H. And again, half mv square equals to E multiply V. Here V is the potential difference between cathode and anode, or maybe it may be accelerating potential. And putting the value of E by H, half m multiply square divided by H square equals to E multiply V. And from this E divided by M equals to square divided by 2 V H square. Now look at this expression. Here is no question of R. No, in this expression the R is removed. So what we need to know? The electrical field strength, the voltage between cathode and anode, and magnetic field strength. From this we can easily work out the value of E by M. So I try my best, friend. It is informative and also give you knowledge in depth. If it is helpful for you, please share, subscribe, and if there is any necessary change, please do comment in the comment section below. Thank you.